profound transformation is quietly unfolding beneath Africa, one that is reshaping the map of our planet. The landmass of Africa is dividing up.
A massive crack in the ground that's estimated to be up to 50 feet deep has opened up in Kenya seemingly overnight.
Recently, Elon Musk reignited global curiosity by describing this phenomenon called the East African Rift as one of the most profound planetary shifts in modern history. The East African Rift is a live demonstration of Earth's evolution. But why is Africa splitting up? What opportunities, risks, and mysteries lie in this unfolding phenomenon? Join us as we delve deep into the science of the transformation at the East African Rift. Discovery of the Rift. In 2005, a team of geologists led by Dr. Tim Wright from the University of Leeds was the first to observe a remarkable rift stretching thousands of kilometers across East Africa. This massive rift opened up across several countries. In fact, it even split a man's house into two. 2 decades since then, it's been evident that Africa is undergoing a continental rift. The rift, named the East African Rift, has been a focal point of global geological research. It was observed as an active tectonic split using satellite-based interferometric synthetic aperture radar, also known as INSAR. This observation marked a turning point in understanding how continents split and provided the earliest detailed evidence of active tectonic plate divergence within the rift. The discoveries made at the site would shock you. Surprisingly, details about this global phenomenon have been obscure to the public until recently when Elon Musk spoke about it. Musk emphasizes that this rift was no simple occurrence. Rather, it's a physical representation of tectonic plates that have been drifting apart gradually over 25 million years. These movements have shaped continents, oceans, and entire ecosystems. But what's happening in Africa now is extraordinary. This isn't a story of ancient geology. It's an ongoing transformation visible in real time. The question many have been asking is, what caused this tectonic activity? The process began deep beneath the Earth's surface tectonic plates. The Somali and Nubian plates are the primary players in this drama. The Somali plate, located on the eastern side of the rift, slowly drifts away from the larger Nubian plate over time. This movement creates tension in the lithosphere, forming cracks, fissures, and rift valleys. The process is further fueled by mantle plumes, upwellings of hot magma from deep within the lithosphere, and drive the plates apart. Massive slabs of Earth's lithosphere rest on a molten magma layer called the asthenosphere. These plates float and move, driven by the heat and dynamics of Earth's core. The East African Rift is a divergent boundary, meaning the tectonic plates beneath it move away from each other. As this happens, magma from the mantle rises to the surface, creating volcanic activities, new crust, and eventually a splitting landmass. NASA has been at the forefront of this Earth-changing event, utilizing satellite imagery and geophysical data. These tools enable geologists to create 3D landscape models that reveal otherwise invisible features to the naked eye. AI and machine learning algorithms further enhance our ability to analyze this data, identifying patterns and predicting future activity. One of the most groundbreaking advancements is the use of geothermal sensors to monitor volcanic and tectonic activity by measuring changes in temperature and gas emissions. Scientists have been able to use this data to map the rift in incredible detail. The rift system spans from the Afar Triangle in northeastern Africa, extending southward through Ethiopia, Kenya, Tanzania, and beyond. In some places, it's visible as a gaping crack in the earth, while in others, it manifests as volcanic ridges or deep lakes. The Afar Triangle is often considered the epicenter of this activity, providing critical clues. It's here that the Arabian, Somali, and Nubian plates converge, making it one of the most tectonically active regions on Earth. Over the next millions of years, this area will likely give birth to a new ocean that will separate Eastern Africa from the rest of the continent. But there are even more interesting details about this phenomenon. This process mirrors what happened millions of years ago when the Earth's continents were formed. Millions of years ago, the Earth was just one massive supercontinent called Pangaea. Driven by tectonic plate activity, the Pangaea began breaking apart into plates approximately 200 million years ago. As the plates diverged, they formed the basis of what would later become the modern oceans, continents, and islands as we now know it. These shifts were powered by mantle convection, a process where heat from Earth's core caused the lithosphere to fracture and drift. The effects of Pangaea's breakup are far-reaching till our era, profoundly influencing the planet's topography, including the development of Africa's Great Rift Valley. Tectonic activity has continued to play a vital force in the evolution of the Earth. It continues to create and reshape rifts, valleys, and seas. The African Rift, for example, is still in its infancy compared to older systems like the Atlantic Ocean. These features provide a window into Earth's evolving geology and future landscape. Other significant rift systems exist globally. The Mid-Atlantic Ridge, which is a submerged boundary between diverging plates, is a key example of how oceanic rifting operates. The Baikal Rift Zone in Siberia is another example of a continental rift system in a colder climate. These two regions are examples of how rifting impacts ecosystems, geology, and hydrology on a large scale, making the African Rift an invaluable comparative study. From the breakup of Pangaea to the formation of rift valleys and lakes, Africa's Rift Valley is a living laboratory for studying tectonic forces and their global implications. Current and future impacts of the African Rift. The African Rift is not just a geological wonder. It has great geopolitical and economic implications. As tectonic activity continues, the formation of a new ocean could reshape Africa's geography, potentially creating new coastlines and altering the status of landlocked nations such as Uganda, Ethiopia, Rwanda, and Burundi. These countries may gain access to maritime trade, unlocking opportunities for economic growth. However, managing this would require significant investment in port infrastructure, trade routes, and governance frameworks to manage new borders and territorial waters. The potential for expanded trade networks is immense. A new ocean would facilitate faster and more efficient transport of goods, potentially boosting regional trade under agreements. Also, rifting regions could become hubs for mineral and energy exploration. The Rift Valley already boasts resources such as geothermal energy, particularly in Kenya and Ethiopia, which could be scaled up to support industrial growth and energy security for these countries. However, these opportunities are accompanied by challenges. Disputes over newly formed coastlines and resources could spark tensions, particularly in regions already affected by political instability. To leverage the rift's economic potential without national conflicts requires strategic planning and international cooperation. Also, the rift's impact on climate is not entirely positive. The volcanic activity associated with the rift releases significant amounts of greenhouse gases, including carbon dioxide and methane, into the atmosphere. While these emissions are a natural part of Earth's carbon cycle, they can contribute to global warming, if not offset by other processes. There is yet another hurdle to cross. The Rift Valley's ongoing tectonic activity presents significant environmental and human challenges. Rising water levels in rift lakes could displace communities. In fact, it is already doing so. In Lake Baringo and Lake Bogoria, expanding waters have submerged homes and farmland. Other risk factors common in rifting zones are volcanic activity and earthquakes. The risks it poses to human life and infrastructure can be very disastrous. For instance, the Nyiragongo volcano in the Albertine Rift erupted in 2021, displacing tens of thousands instantly. Socio-economic conditions in the Rift Valley exacerbate these challenges. The region is home to some of the poorest populations in Africa. These regions already battle with limited access to healthcare, education, and infrastructure. Malnutrition and poverty are widespread, particularly in rural areas, where farming is often disrupted by environmental changes linked to tectonic activity. Without targeted interventions, the effects of rifting could deepen these issues, making it harder for communities to adapt. On the other hand, the rift also presents opportunities for sustainable development. By harnessing the geothermal energy of the rift, it could help reduce humans' reliance on fossil fuels while improving energy access in underserved regions. Countries like Kenya, Ethiopia, and Djibouti have already begun tapping into this potential with geothermal power plants in the Rift Valley. Since its discovery in 2005, Kenya has rapidly established itself as a leader in geothermal development. The Olkaria Geothermal Power Station contributes over 900 megawatts to Kenya's national grid. Ethiopia has also launched geothermal projects, such as the Korbeti Geothermal Plant, aiming to produce up to 500 megawatts. These projects are supported by international partnerships, including the United Nations Environment Programme Initiative, which promotes geothermal energy in Africa. One thing that makes geothermal energy a most preferred option is the fact that it is renewable. It also produces minimal greenhouse gas emissions compared to fossil fuels. This makes it a vital tool in combating climate change while promoting energy access. Geothermal energy reduces Africa's reliance on non-renewable sources such as coal and oil. Much of the continent currently depends on these resources for electricity, which is not only polluting but also subject to price volatility. By diversifying its energy mix, Africa can enhance energy security and stabilize energy costs. Beyond providing clean energy sources, the economic benefits also extend to job creation and industrial growth. Geothermal projects require skilled labor for exploration, drilling, construction, and maintenance, providing employment opportunities in regions where jobs are often scarce. Additionally, reliable energy from geothermal plants can power industries and businesses, stimulating economic development in the Rift Valley and beyond. Also, the Rift's biodiversity hotspots, such as Lake Tanganyika and Lake Malawi, offer opportunities for ecological tourism and conservation initiatives that could benefit local economies. However, as good as all of these sounds, geothermal energy development in the Rift faces several challenges. One major issue is the unpredictability of volcanic and tectonic activity. While these forces create the heat necessary for geothermal energy, they also pose risks to infrastructure and operations. For example, earthquakes or volcanic eruptions could damage power plants, making it essential to design facilities that can withstand geological hazards. In 2005, a massive crack in Ethiopia's Afar region following a volcanic eruption that spans 60 kilometers was a stark reminder of the forces at play. Such events can disrupt communities, displace populations, and strain infrastructure. Preparing for these risks will require intense scientific collaboration, advanced engineering, and global support. Another significant challenge is the lack of infrastructure and investment. Geothermal energy projects require substantial upfront investment for exploration, drilling, and plant construction. In many Rift Valley nations, financial resources are limited, and governments often struggle to attract private investors. To cap it all, the technical expertise required for geothermal energy development is scarce in some regions, leading to reliance on foreign specialists and increased project costs. The lack of reliable infrastructure, such as roads and transmission lines, further complicates the deployment of geothermal energy. Remote locations with high geothermal potential may be difficult to access, delaying project timelines and increasing expenses. But the implications extend far beyond energy. As the rift widens, ecosystems will change dramatically. New waterways and ocean basins could form, altering climate patterns and reshaping biodiversity. Musk argues that these changes could redefine Africa's geopolitical landscape. Despite this roller coaster of challenges and opportunities, there is one thing that many scientists agree on. The African Rift is a natural laboratory. It offers geologists and scientists a unique opportunity to study tectonic processes and their implications for ocean formation. By studying the rift, scientists can gain insights into the dynamics of plate tectonics, the origins of earthquakes and volcanoes, and the evolution of continents and oceans. These lessons have implications far beyond Africa. For example, the knowledge gained from the rift could inform our understanding of other tectonic boundaries, such as the San Andreas Fault in California or the Mid-Atlantic Ridge. It could also help us prepare for future geological events, from earthquakes to volcanic eruptions. Moreover, the rift underscores the interconnectedness of Earth systems. The forces driving Africa's split are the same ones that have shaped the planet for billions of years, creating mountains, valleys, and ocean basins. By studying these processes, we can better understand our place in the natural world and our responsibility to protect it. The rift provides real-time insights into how continents break apart, shedding light on similar processes that shaped ancient features, like the Atlantic Ocean. Researchers use advanced technologies such as GPS monitoring and seismic imaging to track plate movements, contributing to our understanding of Earth's dynamic systems. The rift has also been a study site for geologists, providing valuable insights in paleontology, with fossil discoveries transforming our understanding of human evolution. These discoveries emphasize the rift's importance in offering unparalleled insights into early human life and adaptation. Looking ahead, the rift will remain a focal point for multidisciplinary research encompassing geology, biology, and anthropology. Collaboration between African institutions and international researchers will be key to unlocking the rift's full potential as a source of scientific knowledge. Geothermal energy is just one example of how Africa could capitalize on it. Its unique geology mining opportunities are another. The rift zones are rich in minerals like gold and copper and rare earth elements essential for technologies like electric vehicles and renewable energy systems. Musk predicts that the rift could become a hub for sustainable resource extraction, fostering economic growth and technological advancement. However, realizing this potential will require international cooperation. Competition for access to geothermal energy, minerals, and water could lead to conflicts between nations or communities. Managing these challenges will require strong governance and international cooperation. Musk's vision for the rift emphasizes the need for a collaborative approach to its development. By working together, nations can leverage the rift's potential while minimizing risks. This includes sharing data and resources, investing in sustainable technologies, and fostering regional partnerships. The East African Rift is not just a regional phenomenon. It's a window into the broader processes that shape our planet. Musk calls for a collaborative approach to studying and managing the East African Rift. By sharing data, resources, and expertise, nations can turn this geological challenge into a global opportunity. He envisions partnerships between governments, private companies, and scientific institutions, fostering innovation and resilience. Musk also emphasizes the importance of education and public awareness. As the rift continues to expand, what is likely to happen when it completely splits? The African rift, driven by tectonic forces, is a preview of dramatic changes to Earth's geography. If the current rifting continues, Eastern Africa is predicted to separate from the rest of the continent. This earth-shattering event will lead to the creation of a new ocean. This event, similar to the formation of the Atlantic Ocean millions of years ago, would redefine Africa's physical and political landscape. The rift, caused by the divergence of the Nubian and Somali tectonic plates, stretches from the Red Sea down to Mozambique. Over time, the Somali plate is expected to detach entirely, leaving Eastern Africa as a massive island comparable in isolation to Madagascar. That's not all. This separation would create a new coastline for countries like Ethiopia, Kenya, and Tanzania, while isolating regions like Somalia. These landlocked nations might gain access to the sea, while coastal regions could face challenges from rising waters or tectonic instability. While the idea of Africa splitting into two continents may seem apocalyptic, Musk analysis offers a comforting edge to it. According to him, although the rifting is undeniable, it is an extremely slow process on a human timescale. The changes we see today are merely the opening chapter of a much longer story, yet they offer an unprecedented opportunity to witness and study tectonic processes in action. Known for his love of technology, Musk highlights how technology will be pivotal in understanding and adapting to these changes. Satellite monitoring, seismic sensors, and AI-driven models are already transforming how we study Earth's geology. By leveraging these tools, scientists can predict earthquakes, monitor volcanic activity, and model long-term changes to the Earth's surface. Musk envisions a future where such technologies become accessible to nations worldwide, empowering communities to thrive amidst geological transformation. Scientists estimate that the complete division of Africa will take between 5 and 10 million years, with some early indications of oceanic formation appearing within the next few million years. For example, the Afar Depression in Ethiopia is one of the few places on Earth where the splitting process is visible at the surface, with volcanic activity creating a nascent oceanic ridge. This timeline has mirror predecessors in history. One of them is the separation of South America from Africa during the breakup of Pangaea around 100 million years ago. Just as the Atlantic Ocean expanded, the emerging body of water in Eastern Africa could eventually grow to rival its size, altering the planet's geography once again. The splitting of Africa would have profound implications for global geography, trade, climate, and biodiversity. A new ocean would open up entirely new trade routes, connecting regions in ways that are impossible today. For instance, Eastern Africa as an island might emerge as a maritime hub, facilitating faster connections between the Indian and Atlantic Oceans. However, this would also create new geopolitical dynamics, potentially leading to disputes over maritime borders and resources. The creation of a new ocean would also impact climate patterns. Oceanic currents are crucial for regulating global temperatures, and the introduction of a new body of water could disrupt existing systems. For example, coastal regions around the new ocean might experience increased rainfall, while other areas could become more arid. Biodiversity would also undergo significant shifts. The isolation of Eastern Africa would lead to the evolution of unique species, much like Madagascar's distinct flora and fauna. However, The transformation of ecosystems could also threaten existing habitats, particularly for species dependent on freshwater lakes and forests that might be lost or fragmented during the separation. There's more change to be anticipated. The rift's role in human evolution and ongoing discoveries. The East African Rift isn't just about land masses moving apart. It represents a unique glimpse into the Earth's ongoing evolution. The African Rift Valley is often referred to as the cradle of humanity because it has yielded some of the most significant fossil evidence of early human evolution. Sites like Olduvai Gorge and Lake Turkana have yielded iconic finds. One of the most mind-blowing of such discoveries is Lucy, a 3.2 million-year-old Australopithecus afarensis. Another was the discovery of a nearly complete Homo erectus skeleton at the Turkana Buoy. Others include the Kubi Fora in Kenya and Hadar in Ethiopia. These sites have provided key insights into the development of early hominins. These fossil discoveries showcase the evolutionary journey from ape-like ancestors to modern humans. The rift's unique geological activity created the perfect conditions for preserving fossils. Volcanic eruptions layered sediments over ancient remains, protecting them from decay and making them accessible to paleontologists millions of years later. This region's geological history provides an unparalleled window into the evolutionary past. Moreover, environmental changes driven by tectonic forces in the rift profoundly shaped human adaptation. As the land shifted and the climate fluctuated, ancient ecosystems transitioned from dense forests to open grasslands. This forced early humans to adapt, fostering traits like bipedalism, which allowed for efficient movement across savannas and increased brain size to cope with the challenges of a changing environment. The rift's alternating periods of wet and dry conditions played a crucial role in human evolution. Researchers believe that this climate variability drove the development of key survival traits. During wet phases, abundant water and vegetation supported diverse life forms, encouraging early humans to explore their environment. Dry periods, however, required adaptability and resourcefulness to survive. That's not the most interesting part. Keep watching for more. The East African Rift also underscores the interconnectedness of Earth systems. Musk points out that tectonic activity influences everything, from climate patterns to ocean circulation as the rift expands. It could alter wind currents, rainfall distribution, and even the migration of marine species. Understanding these connections will be crucial for mitigating risks and maximizing benefits. The economic implications of this discovery are vast. The Rift Valley continues to be a hotspot for fossil discoveries, deepening our understanding of human ancestry. Recent finds, such as Ardipithecus ramidus and early Homo species, provide evidence of the diversity and complexity of hominin evolution. Advances in technology, such as 3D imaging and isotopic analysis, are helping researchers reconstruct ancient diets, habitats, and migration patterns. The rift's significance extends beyond fossils. It serves as a natural laboratory for studying how geological and environmental factors influence evolution. By exploring the interplay between tectonics and climate, scientists gain valuable insights into how humans adapted to a changing planet and how we might respond to future environmental challenges. The African Rift Valley remains central to understanding the story of human evolution. Its unique geological and environmental history shaped the path of hominin development, making it a vital region for uncovering the origins of humanity. The African Rift is a major part of the Earth's evolution and its ongoing geological processes. While the splitting of Africa is a slow phenomenon that will take millions of years to complete, its impact is far-reaching. from the geological forces that shape continents to the rift's role as the cradle of humanity and even its potential as a renewable energy hub. This transformative event intertwines Earth's history, human evolution, and future opportunities for sustainable development. The significance of the African Rift extends beyond science. It is a reminder of Earth's dynamic nature, constantly reshaping itself in ways that influence ecosystems, economies, and societies.